Okay, lovely question here on surds. Okay, so as soon as I see roots, I'm kind of thinking back to my surds. Not that it matters that much. We know how to work with square roots even before we were calling them surds. Okay, this question has 2 square root a, and then underneath the fraction, a square root of 1 minus a. And it says express a in terms of x. Okay, so just a reminder of what that is. If I think back to if I had something like x equals 2 plus a, and they said express a in terms of x, it means give what a is and x can be in your answer. Okay, so it wants a on a side by itself and x can be in the answer. That's fine. Okay, so that's what they're asking me to do here. So here I'm basically going to have to rearrange everything to manage to get a on a side by itself. Okay, now if I want to do that, if I look at this here, the roots are very confusing. Okay, so I actually can start by really simply being like, I'm just going to get rid of the roots. Okay, how do I get rid of the roots? Well, in this, I can just square the roots. Okay, which means I have to square the left hand side as well. Now, remember, actually I'm not going to go into it. Okay, so that means x squared is, okay, and then the squared part is going to act on both the top and bottom of the fraction. So remember, in your log tables, if you have a over b to the power of p, okay, so remember to use your log tables for this. It's a to the power of p over b to the power of p. Okay, so that is my 2 square root a to be squared. Oh, what did I just do? Over, and then my square root of 1 minus a to be squared. Okay, this one is probably the easier one to actually see what to do. Okay, because it's just a simple big square root and a squared, they cancel. Okay, this one here, I have 2 things inside the bracket, so I again need to go to my indices rules and see if I have 2 things inside a bracket and a power outside a bracket, what happens? Okay, well, the power acts on both parts. So that means that the 2 is being squared, so that I get 4. And then the squared is also acting on this square root, and they end up cancelling with each other, so that it's just a. So I have 4a over, and then this square root and squared cancel, so I'm just left with 1 minus a. Okay, so now I've actually gotten rid of all of my square roots, and I just need to get a on a side by itself. Okay, so I'm going to start trying to do that. The next most confusing thing is probably that there's a fraction. So how would I get rid of the fraction? Well, I would multiply across by what is dividing. So my 1 minus a. So 1 minus a by both sides. Okay, so if I multiply that out, I will get on the left hand side 1 by x squared, so x squared, and minus a by x squared, so that's minus a x squared. And then on my right hand side, that is going to be equal to 4a. Okay, because these two have cancelled with each other. Now, have I started getting my a terms on one side together? No. But what I have done is made the expression less confusing to me. I've gotten rid of all the roots, I've gotten rid of the fractions, and now I can look and say, right, how would I gather my a terms? Okay, so I'm going to put all my a terms on one side together. So I'm going to move this across to the other side. Or I could move this 4a across and get rid of the x squared to the other side. It's up to you. I'm going to just say, I want all my a terms on the right hand side. So I need to get rid of this ax squared that was subtracting. So how do I get rid of an ax squared that was subtracting? Well, I'm going to add ax squared. Okay, so that on my left hand side, I'm left with just x squared. And on the right hand side, I'm left with 4a plus a times x squared. Okay, so now I've grouped all my a terms. They're all on that same side of the equals together. But I do need to manage to get them on their own. And when I'm doing this, I can't just be like, okay, well, I'll divide across by 4, because then I'll have this also divided by 4, which isn't going to help me get this a over here by itself if I have it being divided by 4. Okay, so I don't want to just go straight into trying to divide what's multiplying the a's yet. Instead, I want to try and just see, is there another way that I can kind of pull the a's together and maybe factorize them out. Okay, so see the way there's an a here and an a here. Could I factorize them out at all? Or could I look at the 4 and the x squared as coefficients of the a's? Okay, so let's look at it again, and let's say, right, what if I factorized out the a's? So do highest common factor here. Okay, so factorize out the a's and be left with 4 plus x squared. Because now it's really clear what I need to do to get a on a side by itself. Okay, I just need to get rid of this thing here that's multiplying it. So to do that, I have to divide by my 4 plus x squared, which means I have to divide this side also by 4 plus x squared. Okay, so that I am left with, on the left hand side, x squared over 4 plus x squared, and on the right hand side I have a. Now, if when you are doing this out, if you start and you get some of these squared out correctly, okay, only some of them, then you can still get 4 out of 10 marks. But you have to recognize there that you're going to start squaring, and you have to get some of them squared out correctly. Okay, so maybe the 1 minus a out correctly, or the 4 out correctly. If you get all of them squared out correctly, and you correctly eliminate the denominator, so you multiply across by 1 minus a, so that you get this equation here in black, you have gotten 70% of the marks. You've gotten 7 out of 10 marks there. Okay, if you just got what I had here in black and you didn't start to multiply across by the 1 minus a, you are stuck on that 4 marks there. Okay, but it is still 4 marks. You have still passed the question. Okay, and then to the very end here, we manage to get our full 10 marks.